Okay, here we go. 1.8, we are looking at some properties of real numbers. The first one we're going to look at here is the commutative property, and now we're going to look at two different commutative properties. So first we're going to look at the commutative property of addition. So now what the commutative property is all about is moving things around. It has the same base, this commute part of it here, is the same base as, commute, like commute to work. So that can help you remember which property is which if you think about commuting and moving around. So what the commutative property of addition says that if I have some number, here's a, and I'm going to add something to that. I'm going to say a plus b. If I'm just adding those two things together, then a plus b is exactly the same as b plus a. So basically what this property is telling me is that if addition is the operation I'm using here, I can do it in any order. So here's a little example down here of what's going on. X plus 5 is exactly equivalent to 5 plus x. And that is by the commutative property of addition. We also have a commutative property of multiplication. And very similarly, that says if I take two numbers and I multiply them together, if I have a times b, that is going to be exactly equivalent to b times a. So here's another little example down here. And some of these problems, and these can, sometimes they confuse people just because they don't understand what they're being asked to do. They'll say, use the commutative property to rewrite the following expression. What you would do here is instead of x times 8, you can use the commutative property to rewrite that as an equivalent expression to 8 times x. So one thing to be really careful of is this is all exciting, but these do not hold. So note, these do not hold for subtraction or division. Subtraction or division. So here's just a little example of that. Like if I have 9 minus 1 equals 8, but 1 minus 9 is equal to negative 8. So those are not the same. Those are not equivalent expressions. And that's why it can be helpful. One of the reasons it's helpful sometimes to change subtraction to multiplication, or change subtraction to addition of opposites. So let's go down here and talk about the associative property. The associative properties are a little more abstract, I think. The associative property of addition says this. If I have two things that I'm adding together, if I have like a plus b, and I'm doing that first, and then I'm going to add c to that, that is equivalent, so that is the same as a plus b plus c. And I think one thing that people get confused about with this property is it's sort of hard to tell what happened. But the idea is here, in this first one, I would do that a plus b first and then add c to it. And in the second one, I'd start over here and I'd add b and c and then add a to that. So sort of what it's telling you is that if you're just doing addition, you don't always have to, you can move the parentheses around and you don't always have to be real strict about going left to right. And here's an example of that in action, because people are like, why would I care about that? So here, because I have these parentheses, I would ordinarily, from my order of operations, want to start adding 3/4 to 2. But then I'm going to have to convert 2 to a fraction. I'm going to have to find common denominators. But you can see that this is fourths and this is fourths. So what I can do is use the associative property to take this and write it like this. 1/4 plus 3/4 plus 2. And I can move those parentheses from doing these two first to doing these two first. And I think this is a good example of why this is cool. So here I would do this. I add those together. I get 4/4 plus 2. And then 4/4 is just 1. So I get 1 plus 2. And that is equivalent to 3. So that's the associative property of addition in action. Then we also have the associative property of multiplication. And that says a very similar thing. If I have three things, if I have like A times B, and those two things are supposed to be done first, and then I'm going to take the result of that multiplication and multiply it by C, that is the same as taking A and multiplying that by B times C. So you can do this multiplication in any order. So the commutative property lets you switch things around in the order, and the associative property lets you attack things in a different order. Here's an example of using a few of these properties at the same time. So first of all, what I'm going to do, looking at this, is I don't know what x plus 12 is. And we'll talk in chapter 2 about like terms, but these are not like terms. So I can't just put those together. But what I can do, first of all, I'm going to use the commutative property to change the order that those two things are written. So I'm going to use the commutative property to rewrite this as 10 plus parentheses, and then instead of x plus 12, I'm going to write that as 12 plus x. And then I'm going to use the associative property because I don't know how to add 12 to x. And I would love to get this 10 and 12 together, and I can actually do that using the associative property by changing where those parentheses go. And then I have 10 plus 12, and then I'm going to add x to that, and then 10 plus 12, I can just do that. So I have 22 plus x. And now those cannot be combined because I don't know what x is. So that's actually as simplified as that gets. And here's another one here. And this is the kind of thing you might just do this automatically. And generally people do this automatically and don't even think about the associative property. But the associative property is what is happening kind of under the hood. So here, I don't know what 7 times x is, so what I'm going to do is just pop those parentheses over here and do negative 3 times 7 first, and then multiply that by x, and then I end up with negative 21 times x, and that's how I would leave that. Okay, on to page 2. Okay, so those properties so far, they've just been some stuff for addition, some stuff for multiplication. And what the distributive property is about is what happens when addition and multiplication are hanging out together. So the distributive property says this: if I have something, here it's going to be A, and that's being multiplied by something, so I've got something in parentheses next to it, but the thing that it's being multiplied by contains addition. So here I have like B plus C. So what the distributive property says is this is the same as A times B, so A times the first thing plus A times the second thing. And the reason that it's called the distributive property is you can kind of see, it seems like this A is, some of the A is going to the first one, then it's also going to that second one. And I will often draw those arrows to illustrate what's happening here. So here's an example, 2 times x plus y. I can't combine x and y. So there's nothing I can do inside those parentheses, but what I can do is take that 2, bring it to the x, bring it to the y, so I end up with 2x plus 2y. And then that's considered fully simplified. And again, we'll talk about why I can't just add those things together and what like terms are about in chapter 2. Another way to think about this, and I think this is neat, is 2 times x plus y. 2 multiplication is repeated addition. So in the same way that like, here I'll go up here, 2 times 3 is the same as 3 plus 3. 2 groups of size 3, I can think about the distributive property as being 2x plus y. So I'd have x plus y plus another x plus y. And then when I add all those together, in this case I can drop the parentheses. And then I have an x here, I have an x here. The total number of x's I have is 2. Then I have a y here. I have a y here. The total number of y's I have is 2. So I end up with 2x plus 2y. And so that works nicely when it's just a 2 out there. But something like this, I don't want to write x minus 3y plus x minus 3y plus it 5 times because that would take forever. So the distributive property is sort of a shortcut for that. So in this case, the 5 is going to distribute to that. It's going to distribute to that. It does not go to the z because the z is not inside the parentheses. So it's only going to distribute to the things inside the parentheses that it is next to. So like these parentheses limit how far that 5 can go. So I end up with this 5 times that first thing. My first thing there is x. Then that sign is going to stay the same. And man, you can get yourself into a lot of confusion with these signs. And we'll talk about this a lot as we move forward. But that subtraction symbol stays a subtraction symbol. Then I'm going to add, so after all this is done, then that plus z is going to happen. So now I simplify everything I can. 5x, there's nothing more I can do with that. So I just have 5x minus 5 times 3 is 15 times y plus z. There we are. And that is my fully simplified answer. Now here, this looks really similar, but you can see what's different is that now the parentheses, all 3 of these things are inside the parentheses. So that 5 is just going to distribute to every single thing inside those parentheses. And I end up with 5 times x minus 5 times 3y plus 5 times z. And now I simplify this as much as I can. 5x is going to stay how it is. Minus 5 times 3 is 15. Y plus 5z. So there I go. Okay, let's scroll down here. So this can be pretty tricky with negative signs, and I am going to use this idea that the addition or subtraction symbols in here are going to stay the same. So that addition is going to stay the same, that subtraction is going to stay the same, these guys are going to stay the same. But now the thing that's getting distributed out here, like this negative 5, is going to keep its sign. So I'm going to not do any sign steps in my head. So this is what I'm talking about. I'm going to take this negative 5. That negative 5 is getting distributed to a negative 3. So I have that. And now I'm going to leave that plus symbol the same. And then that negative 5 goes here. And then I have 2z is the other thing that the negative 5 is getting distributed to. And now I can go through and just simplify these two terms. So I have this term first, and then I'm going to deal with that term, and then I'm going to deal with how they combine. So negative 5 times negative 3, a negative times a negative is positive, so that's positive 15. I'm going to keep that plus. And then negative 5 times positive 2 is negative 10 times z. So I have negative 10z. And now, because I'm adding a negative, I'm going to change that in my final answer to a subtraction symbol. That's considered to be like fully simplified. So 15 minus 10z. But I'm saving that until the end. And a lot of people, especially when you do a lot of these, maybe you'll start to see these patterns and you won't have to show every single one of these steps. That's cool as long as you are getting the right answer every time. Now the thing that I'm distributing is this negative 1. So I'm going to have negative 1 times 2. I'm going to leave that subtraction symbol the same. And then my negative 1 is going to get multiplied by y. And this, here's the thing. This is a positive y. 2 minus positive y. So that y is going to stay positive. And basically there's one little horizontal line up here with this y. Take that out. Okay. So now I'm just going to simplify, leaving that subtraction symbol the same. Negative 2 minus negative 1 times y is negative y. And now minus a negative, I can rewrite that as negative 2 plus y. Now for this one, having this negative out here, there's a lot of different ways you can think about this. One way is having a negative out there is the same as multiplying by negative 1. So just having a negative sign outside is the same as this. Negative 1 times 3 plus x minus w. And then that is going to distribute to every single one of these. So negative 1 times 3 plus negative 1 times x minus negative 1 times w. And now I can go through and simplify all those. Negative 3 plus negative x minus negative w. That's the same as negative 3 minus x plus w. You can also think about that as another way to deal with distributing a negative sign is this two-step process. So here's an alternative method. Alternate method. And then you would distribute a negative sign in 2 steps. 1, change the sign of the first term. And then your second step is going to be switch each operation after that. So switch each operation after that. So what I would do is, this was positive 3. I'm going to make it negative 3. Then I'm going to change that plus to a minus. So minus x. And then I'm going to change that minus to a plus w. And so either way, I get the same answer. Yeah, and it really is whatever works best for you. Okay, here we are on page 3. These are just some more properties of some of these numbers. So the identity properties, and we talked about this a little bit in class. So the identity property, the identity for addition is 0 because A plus 0 equals A. And so this is what being an identity is about. If I add 0, it doesn't do anything. So adding 0 doesn't change a value. Then we also have an identity property for multiplication. The identity for multiplication is 1 because if I take any number I want, like A, times 1, I just get that same number back. So multiplying by 1 doesn't change anything. Multiplying by 1 doesn't change a value. Okay, we've got 2 more properties, and then I've got a couple problems for you guys to try here. So the inverse properties, and this is again something we talked about a little bit last time. Numbers are additive inverses if they sum to 0. So 2 numbers are additive inverses if they sum to 0. And the reason it's 0 for addition is because 0 is the additive identity. So A and negative A and negative A are additive inverses because A plus negative A is the additive identity. Right there. And then 2 numbers are multiplicative inverses if their product, so now I'm talking about multiplication, is the multiplicative identity, which is 1. And we talked about this last time when we were talking about reciprocals. So I have like A and 1 over A and 1 over A are multiplicative inverses. Because A times 1 over A equals 1, and 1 is the multiplicative identity. Okay, so then I've got these couple group problems, and I'm going to do that same thing where I post solutions as an image file on the D2L page. And this time I will check to make sure that they do actually match, and it looks like they do. Okay, cool.